Imagine an array of elements, each connected to the other, each pointing to the next element in the list. If we want to access a specific element, we need to start with the first value and then walk through each element to find the value we're looking for. This is known as a singly linked list. In such a list, each element contains a .next property that holds the reference to the next element in the list. There are two main parts of the list, the head and the tail. Generally, we start from the head and then walk through each element one by one. If we want to add a new element to the list, we could do one of two things. We could either insert it first and replace the current head, adding a reference to the previous head in its .next property, or we could add it to the tail and replace the current tail. But to do that, we would need to find the tail first. That's where the first weakness of our singly linked list comes into play. If there isn't a tail defined, we would need to walk through each element starting from the head in order to find the tail. There is no other efficient way to reach the tail. As you can figure it out, it's highly inefficient. As the list grows, so does the number of operations, so finding something in this list can be pretty inefficient. Still, this data structure has a few advantages over something like a traditional array. The main one would be that each element is dynamically allocated instead of fixed allocation. The size of each element in this list can be independent from the rest of the list. It can change over time if it wants to, and it wouldn't affect anything else in the list. Whereas in an array, it is expected that every element of the array is of a single type. A linked list also allows us to efficiently remove any elements from the list, whereas shifting of elements is required whenever an element is added or removed in the array. A great example of a singly linked list would be a queue. Let's implement a queue in TypeScript. Here we have our queue class. Let's start by defining the type of our element. Each element will have the value and a .next property that will hold the reference to the next element in the queue. Also, let's define a few variables such as the length, the head, and the tail of the queue. When initializing our queue, it's going to be empty, so let's set this .head and this .tail to undefined. We can also set the initial length of the queue here, which is going to be 0. Next, we can define our inQueue method. It's going to take the item that we want to add to the queue as a parameter. It's going to be of type generic T, which means it can be of any type. We can create a new node object and set the item as the value. As the queue is a FIFO type structure, we will be adding this new node to the end of the list. For that, we need to check if there is a tail. If there is no tail, that means there is no head either, and the queue is empty. So we can set this .head and this .tail to this new node and return. But if we do have a tail, we can simply set the .next property of the tail to point to this new node. Also, we need to update the current tail and set it as the new node. Let's define the dequeue method next. Dequeuing an item means removing it from the queue. So we are taking out the current head of the queue. For that, we can simply check if an head exists. If it doesn't, we can simply return undefined. But if it does, we need to update the length of the queue and set the next element in the queue as the new head. Then we simply return the value. If we want to simply peek at the next value in the queue, we can simply use the peek method, which will return the value of the current head. Doing this will not remove it from the queue. And that's all there is to a queue. At its core, a queue is a prime example of a singly linked list. In the real world, you probably won't encounter a singly linked list out in the wild. But it is still a fundamental data structure that helps us visualize complex elements better. Thank you for watching my video. If you like my content, please hit the sub button and leave a comment. And I'll see you in the next one.